Hi everybody, in this video we are going to be looking at the solution for Physics 1 complex circuit due right now 2. So let's take a look at this circuit. Again, there's a lot going on in this circuit. It can look confusing at the beginning, but the goal is just to simplify what we can little bit by little bit to try to find equivalent resistances wherever we can. Typically with these types of problems, I generally like to start as far away from the battery as I can get. That's not a rule. That doesn't always work, but it usually gives you a good starting point of places to simplify. So if I look at what I have in this circuit, if I go over to these two resistors right here, this 3 ohm and 12 ohm resistor, they are in parallel with one another, and I can find the equivalent resistance of just those two. When I look for the equivalent resistances for those two, again, the inverse of the equivalent resistance is equal to the inverse of the sum of the individual resistors. So I take the inverse of my 3 ohm resistor, the inverse of my 12 ohm resistor, take that sum, find the inverse of that, and I'm going to find an equivalent resistance of 2.4 ohms. Now I know that that 2.4 ohm equivalent resistance is in series with this 4 ohm resistor. So I can find the equivalent resistance for that combination, my 2.4 ohm resistor and my 4 ohm resistor. I just need to add them up because they're in series with one another, and that will give me an equivalent resistance of 6.4 ohms for this whole combination. So that's 6.4 ohms. And I know that that entire combination is in parallel with that 6 ohm resistor here. So I can find my equivalent resistance for this whole group. And I know that because they're in parallel, I have to use my inverse formula. So the inverse of 6.4 ohms, which is my combination of the first 3 resistors, plus the inverse of my 6 ohm resistor, take the inverse of that sum, and I'm going to be given an equivalent resistance of 3.1 ohms for this whole combination. So that whole combination is 3.1 ohms. Okay, just to review what we've done so far, I know that this whole combination of resistors has an equivalent resistance of 3.1 ohms. And I know that combination is in series with this 5 ohm resistor. So I can find the combination for this whole section right here, because I know that the 3.1 ohm combination is in series with the 5 ohm combination. I add those together and I get an equivalent resistance for that whole section of 8.1 ohms. And I know this whole 8.1 ohm combination is in parallel with this 8 ohm resistor. So I can look at this whole section right here and find the equivalent resistance for that. Because they're in parallel, I have to use my inverse formula, and I plug in my 8.1 ohm equivalent resistance plus 8 ohms. That is going to give me an equivalent resistance for this whole part of the circuit of 4 ohms. Okay, just to recap, I know that this whole combination is going to be 4 ohms. So that is 4 ohms. And I know this 4 ohm combination is in series with this 10 ohm resistor. So I can find the equivalent resistance for all of these now, right there. 4 ohms plus 10 ohms is going to give me an equivalent resistance of the entire circuit of 14 ohms. Now, what they're actually asking us to find is the current through the circuit. So I know the equivalent resistance of the circuit, I know the voltage of the circuit right here, 24 volts, so I can use Ohm's law to determine the current. The current is equal to the voltage divided by the equivalent resistance. So 24 volts divided by 14 ohms is going to give me a current of 1.7 amps.